My name is David Day. I'm the Senior Manager for Technical Delivery. And I'm joined by Kyle Gleed, who's the Senior Manager for Technical Marketing. And we're going to run through deployment considerations for ESX, just while a few people are coming in the room. I look after the VCI program for VMware, the Certified Instructor Program. We've got a session running 2 floors down, and we just had a password reset. So they were asked to choose an 8-character password. So someone said, yeah, choose Snow White and 7 Dwarfs. That didn't go down well. I won't try that one again. Okay, so let's get going. I'll just take you through the housekeeping first of all. Of course, just as a disclaimer point of view, as you know, the product's just GA'd, so a few of our screenshots might look slightly different, but just take a few seconds to read through it. This just means you can't hold us to any of this, that's all. All right, so here's our agenda. We're going to run through just the overview of ESXi and the key differences between ESX and ESXi. As most of you should be familiar with, the key difference, of course, the loss of the service console. We'll have a brief discussion about what the impact of that is and how do we do the things we used to do on an ESX platform on ESXi. So how do we interact with the system? And then we'll take you through Image Builder. And Image Builder is a way of packaging up an installable image. And we'll take you through how you can modify that image before deploying it out. And then on to some deployment options. Right? So how can we roll this thing out onto a number of servers? How do we tie in Update Manager? What do we do around kickstart files, for example? And then on to the auto-deploy, which is where the image builder and the deployment functionality comes together. And then finally, we'll have a look at just a few considerations post-install. So once I've got these systems deployed out, what additional things should I be looking at? For example, core dump partitions, scratch log partitions, lockdown mode, and what impact that's having on the system. Right, so Kyle and I are going to swap through as we go through the session, and hopefully you'll find it informative. So this is a slide you'll probably see at all the sessions you go through, really just how the migration process and the adoption of virtualization moves through, starting off with the infrastructure focus, hitting those base images, those systems which are typically running legacy hardware and so on, getting them up onto the virtualization platform. And then as the conference grows, shifting into the software, getting those mission-critical software apps in a virtualized state, and then finally into IT as a service. Right, so you'll get used to this as you go through all the different sessions. Okay, so let's get going. ESX5 is the first release to have the exclusive ESXi hypervisor. And the service console has been removed from this. Now, the removal of the service console means that we provide significant more resources to the ESX servers and to virtual machines, predominantly because we don't have this, this nice big squatter sitting on the system that's busy chomping up resource and making our deployment options and our partitioning structure complicated. But of course, there were certain things that we relied on the service console to do. So how do we do the things that we used to do? Right? How do we get these things to run in what is effectively a service console-less environment? We'll look at the differences between the different interfaces that we can use. But the vCLI and PowerCLI are still available for command line-based tasks that we need to perform. And particularly around the auto-deploy function, we're going to make use of PowerCLI to get that system up and running. In-place upgrades are still available for ESX and ESX4, so 4.0. So when we shift up into ESX5, you'll see a little bit later on in the slides, I'll just give you a high-level overview of what that process looks like. But we can sit inside a virtual center and we can use Update Manager to pull new systems in. It's just what the structure and how those systems look when we pull them in, and what dependency we have on Virtual Center Server. So we can stage servers to be deployed with all the necessary information that we need, but we need to understand what we have and what we haven't got. So base ESXi installs don't necessarily have the different components that we're looking for. So looking at the architecture, in the VM kernel, we have the VMware Management Framework, right? So that's where the agentless system management, onto the SIM model for our hardware monitoring, and we've got the CLI components that allow us to get the configuration and the support, so making different command line level changes. Of course, we still have things like infrastructure agents, NTP syslog, Active Directory agents, and so on. Those are sitting in the VM kernel directly. And the virtual machine support and resource management, either done directly on the server or through Virtual Center Server. So if we compare this as to the service console that we had originally on the classic ESX versus ESXi, so management agents are now vAPI based. Right. And the third-party agents we can install into an image before we deploy it out. And that allows you to do a couple of different things. You can create install images which are traditionally smaller than the base install image. So if you want a small footprint on the system, you can customize that image before deploying it out by removing key variables as you deploy it out. The SIM providers, agentless SIM-based. And, of course, vCLI and PowerShell, which allow us to make modifications to the configuration commands that we typically run. And then under the infrastructure server agents, we've got the local support console. So you do still have a console that you can interact with on the server. Right? And that will give you a look and feel for the traditional commands that you would have run usually through some kind of service console interface. Some of the command sets have been depreciated, and we'll give you a small table on that coming up later on what those variables look like and what you could do in 4, what you can now do in 5. And of course, we still got the native agents, host D, which is the kingpin. Right, host D is the command set that allows us to interact directly with the server. We've got VPXA, right, which is the virtual center server agent, NTP, syslog, SNMP, and Active Directory under, etc. So those agents still exist, and we can interact with them the same way we used to in version 4. So we can check the status of those services, we can restart them, or start them up. So let's have a look at the image builder. So images are comprised of a couple of different things. We obviously have the core hypervisor, that's the key functionality. We can include SIM providers, drivers, and plugin components. Right? And the base image has some of these components in place. But we may want to take some of them out, or we may want to install new agents, new SIM providers being third-party drivers, or new plugins. And we can create those images in a state that's ready to rapidly deploy out to multiple systems. So the challenge is that we don't necessarily have the right type of image that we're looking for. So we don't have the necessary content that we want. So we want to be able to take an image and customize that image, either by stripping things out or adding new things in. Right. So the image builder is handled through PowerCLI. And all we're simply going to do is we're going to hook into PowerCLI, and we're going to pull down a installable image of some kind. Right. And then we're going to introduce or look at the VIBs inside there, which are the vSphere information bundles. And these VIBs allow us to either make a smaller ESX version or add new functionality into the system. So what we're going to do over the next couple of slides is take you through how you would get the software depot down, how you would create a profile around it, and then modify the VIBs on it. So we can add new drivers in, we can add SIM providers in, patches or updates, and any third-party software solutions to create the ideal master image that we use to deploy out. And bundled with PowerCLI, so no additional installation needs to be done here. And the PowerCLI can sit on an external server or a workstation of some kind, and then we simply connect into the virtual center server. So the 3 key components of the image builder are, first of all, the vSphere installation bundle, which is the software package itself, and typically contains a base set of installable components that we can modify. And as I mentioned, we can add new or take them out or customize. The image profile is the ESX image and the VIBs, and then finally the software depot, which is a collection of the VIB and the image profile, because you may have a multiple number of depots that you want to deploy from. For example, different types of ESX platforms, hardware platforms that require different installation bundles. And you can call different installation bundles and deploy them onto the servers that are necessary. You can create multiple software depots and deploy them out to appropriate servers. So an ESXi image is this customizable collection of software packages that we need. And they're comprised of VIBs. There has to be a VIB of some kind or a collection of VIBs. And they can contain the ESXi software, the drivers, some modules, any third-party apps that you want to include. They all come with an acceptance level, and the acceptance level is the level of testing that's been done. So a VMware certified acceptance level means VMware has certified and tested all the VIBs inside that software depot and verified them that they work across all the different platforms. VMware accepted means that VMware has done testing, but not full scope testing. So they verified it, but they haven't done full-scale testing on all different scenarios and environments. Partner supported and community supported mean just that a partner recognized by VMware has tested that, and it's verified as a partner supported. And community supported effectively means that someone in the community has verified that that VIB may work. All right. So these acceptance levels are something that we include when either creating a new set of images or looking at existing images. You can see what the acceptance level is. And that just really depends on the amount of testing that's been done in the back end. So how do we go about building these images? Well, we have a Windows host with PowerCLI. As we mentioned, the image builder is included in PowerCLI. So we start the session, connect up to the virtual center server, and we can now look at the software depots. The software depot is really just what we're going to pull down for the base image, at which point we can clone it, or customize it, or create new images from it. So we connect up to the image profile, and then we can include different VIBs. Right? We can remove VIBs. We can include our different drivers, right? Third-party application software, any OEM VIBs that we want to modify or include. What we get on the output is we either get a Pixie bootable image, right? And we'll see a little bit later on how we can manipulate the Pixie boot image to be installed in different ways. Or we can create an ISO image. Right, so we have different ways of deploying out the end result. And that then gives you your platforms that you can start telling servers what they should boot from. So we'll probably focus predominantly on the Pixie Boot image just for the sake of automation. So this is a screenshot of connecting up to the virtual center server, and then we've added ESX software depot, and we've specified the location of the depot. And the depot can be, you can pull down a base depot from the download section under ESXi. And they're typically zipped, right? So we now run the get ESX image profile, and that shows us what the different profiles are that are available. So once we've got these in place, we can now manipulate them. So the next step, once we've got these image profiles down, is we can run get ESX image profile, and we can either create a new one. But best idea is probably to clone an existing one, so you've got a fallback to look at. So in this example, the second highlighted section there is new ESX image profile. Clone that profile that we've got listed up at the top there, which is ESXi 5 standard. We give it a name called custom profile, and we specify what the acceptance level is going to be. For example, partner supported. So what we've effectively done here is we've simply cloned off a new profile, and we've given it a name of custom profile. So what we're going to do with this custom profile now is remove or add VIBs. So here's the VIBs. And in this example, we've gone ESX software package image profile. Right up at the top there. Add ESX software depot. Specified an IP address and a location for a VIB. And in this example, the VIB is vSphere HA depot. So this VIB will install the HA agents necessary. So if you didn't have a virtual center server in place, or you wanted to ensure that that variable was in place when you created the image, you're simply installing a new VIB. And add ESX software package, the image profile that we called it was custom profile, and we can see the package is now being created for us. Likewise, you can remove the VIB as well, so you can make modifications to those VIBs. You can also see a collection of what VIBs are available in the install package. Right, so this is just an expand property VIB list, and it shows you all the different variable information packages that you can see. And you could verify that you've installed the correct VIB into the right place. Okay, and then finally, we need to either export and save the profile that we've created. So export ESX image profile, it's called custom profile, and export bundle, and in this case, we're going to create a zip image of it. The second example is export to ISO, and as I mentioned before, you can create the ISO image that you need to deploy out. So it's pulling down the ESX software depot, creating or cloning that depot, and then adding in or removing variables that you want to add in or increase. So whether that be a software, whether that be a verified VIB from VMware, or whether that be a third-party agent. Okay, I'm going to pass over. So Kyle, I'm going to pass over to Kyle for the second portion of this, which is the deployment options.
All right, thanks, David. So yeah, I'm going to go over the deployment options. So what David just went over is pretty much, in a nutshell, how to create and maintain those ESXi images. So now that I have the ESXi image I want, how do I go about deploying that on my host? So ESXi 5, many installation options as far as media types and methods. Most of these are going to be familiar because most of them we had in ESX 4.x. The big ones to stand out here is the auto deploy, the diskless, the ability to install directly the ESXi image directly into the host memory and run it from memory without having a local disk. And then also the support for Pixie booting to enable that. So those are the two I'm going to focus on. As you can see from the slide, most of the other options are similar to what we've had in the past. A little word on scripting installations here. So a lot of interest in scripted installations. You can do scripted upgrades as well. So with your upgrading from 4.x to 5.0 and you want to script it, you can do that. It's the standard scripted method. You're going to go out and create your configuration script. The script that's going to basically have the information where you're going to tell the variables as far as how you want to do the installation. There's sections in there for calling your custom scripts, your pre-install script, post-install script, first boot script. And essentially the way that works is you simply just, when the host boots up and you get that bootloader screen and it starts to count down, if you do a Shift-O, and then basically open up the options, and in the bottom there you can see you do an mboot, and you basically pass in the name of the configuration script along with the bootloader, and it will basically start the boot process. It will use the information in your script to do the configuration. So this is kind of this slide's kind of a repeat of the previous. The graphic there just kind of shows how you could do the scripted installation for doing a Pixie boot as well as doing a boot from a CD or a USB. The scripts, when you want to create the script, the ks.cfg, the default is included on the host in ESXi VMware Weasel ks.cfg. So you can basically, you install your host, you can take that off as a template and edit that and create your own and then use that. So that's a good place to get the script. With one note on regarding a Pixie boot. So Pixie boot's becoming quite common. I've seen a lot of people doing it. Pixie boot, there's two types of Pixie boot. You can Pixie boot without using auto deploy. So a lot of times when I talk to people about auto deploy and we talk about how auto deploy uses Pixie boot, a lot of people associate the two. You can Pixie boot the host without using auto deploy. So again, auto deploy is when you're installing in memory, you're going with a diskless install. You can Pixie boot the host and install on disk as well. So Pixie boot is just basically a network boot where you basically go in and you set up the host to, when he boots up, he goes out, contacts the DHCP server. The DHCP server is going to assign him an IP address, give him all his settings, going to make sure he's registered in DNS. In addition, the Pixie boot, the Pixie boot infrastructure, the DHCP server is going to need to provide 2 additional bits of information to the host. The name of the next server, the name of the TFTP server, and then the name of the file they need to download from that TFTP server. So if you look at the DHCP options, that's option 66, option 67. You can use any DHCP server as long as they support option 66, 67. And then also you need to have that TFTP server. And again, if you have an existing Pixie boot infrastructure, you can just use it. There's no need to have a dedicated infrastructure just for ESXi. So now I'm going to go over auto deploy because, like I say, that's the new piece and that's probably the most interest to most folks. So auto deploy is new in 5.0 and essentially it's a method. It's based on Pixie boot and it basically works with Image Builder. So you need to use Image Builder to go in and create your image. So what David just talked about as far as going out, identifying the image, adding, removing my VIBs, and having everything I need. And then I save that off as either an ISO or a zip file. And then I go in and I basically set up my Pixie boot infrastructure, and then I take there's a new server, the auto deploy server. So it's when you install the vCenter in the vCenter installation media, you launch the auto run, you'll see there's a new option there for auto deploy server. So you can deploy the auto deploy server on a Windows host. You can put it together with your vCenter server, or you can keep it separate. And what it is basically the auto deploy server, and it's essentially a web server, and it has it's out there, and you're going to have the image that you're going to install on that. And then the interface to auto-deploy is PowerCLI. So similar to Image Builder, it's based on PowerCLI. And the way it works is the host boots up, goes out to the DHCP server. The DHCP server points him to the TFTP server, which then redirects him to do a web-based boot off the auto-deploy server. When he does that web-based boot, the auto-deploy server is then going to basically process the host information against a set of rules to do some pattern matching. And what he's going to determine is what image profile, what host profile, and where in vCenter to put the host. And then he's going to basically just proceed to do the installation. And I'm going to go over that in a lot more detail in the coming slides. The big benefit for auto-deploy is there's no boot disk. So you're running everything out of memory. You can quickly deploy large numbers of hosts very quickly. Simply racking a server in a rack, powering it on, and as long as it can DHCP boot, it can go out, get its image, and it can be up and running ESXi very quickly. You have all your hosts can share a consistent image, so configuration drift when you have large number of hosts is a concern. With auto-deploy, since everybody's going to be booting off the same image, if you need to propagate a change throughout 50 hosts, all you got to do is update the source and then reboot those 50 hosts, and everybody's up running off the same image. And using HA and vMotion and stuff, you're able to vMotion the VMs off, so you're able to do all this without any VM downtime. And in addition, if you have a hardware failure, if a server goes down and it needs to be replaced, you can simply just boot another set of CPU and memory up off the same image profile and replace that. So host 1 is no longer tied to that physical disk inside a physical server. Host 1 can be any server that, any set of CPU and memory you have. Okay, so let's just kind of compare a little bit about without auto-deploy and with auto-deploy. So without auto-deploy, the image is tied to that physical server, like I mentioned. With auto-deploy, it's decoupled. So you can basically just, any set of CPU and memory can take over the identity of any host. With auto-deploy, a very simple deployment method. There's a little bit of setup up front, but once it's set up, you can rapidly deploy lots of hosts. You don't have to maintain any custom scripts, no kickstart scripts, no pre-install scripts, post-install scripts. That's all automated, part of the auto-deploy, so very flexible, very agile. And the configuration drift, again, because every time the auto-deploy host boots, it's like a fresh install. So you don't have to worry about getting into situations where over time the configuration drifts and you end up having different configurations on different hosts that could affect HA and things like that. So I've mentioned the disk goes away, so where does this information go? So the image profile that's built and maintained by ESXi Image Builder, that's going to, when you go into the auto-deploy and you go into the PowerCLI, one of these steps is to basically assign an image profile. And when you do that, that image profile will be uploaded onto the auto-deploy server. The configuration, so all the host configuration information, so all the vSwitches, port groups, and settings, and multipathing, all that stuff gets stored in host profiles. So auto-deploy is kind of tied together with host profiles, and because host profiles are used to do the host configuration. And then all the data obviously is stored in vCenter. And then when it comes to log files and core dumps and things that normally go on the disk, you can basically go in and you can set up and you can have those things logging to other data stores. And we'll talk about the new ESXi syslog collector and the dump collector that came out in 5.0 to kind of help facilitate working with auto-deploy. Okay, so the components of auto-deploy. The Pixie Boot infrastructure, of course, and again, this does not need to be dedicated to vSphere 5. If you have an existing Pixie Boot infrastructure, you can use it. If you don't have one, basically it's a DHCP server and a TFTP server. Any DHCP server, as long as it supports option 66, 67, will work. Any TFTP server will work. The auto-deploy server itself, and again, the auto-deploy server comes, the binaries to install that come on the vCenter installation CD zip file, so you can get that from there. If you're looking at the Virtual Center server appliance, the new web-based vCenter, just be aware that the auto-deploy server comes bundled with that automatically. So if you deploy that, there's no extra step to add because it's already there. The image builder, again, the image builder is required because you need to use image builder to create that image. And then the vCenter server because we need the host profiles, and that's where the information gets stored for the host. So let's go ahead and let's now talk about how all these things tie together. So on the screen here, what we have is on the left-hand side, we have the image builder components. We have our software depots and our VIBs and the things we use to create our installing image. In the middle, we have the auto deploy server. And remember, the auto deploy server is essentially a web server where you're going to do a web-based boot, and it's basically going to copy that image from the auto deploy server onto the ESXi host. And then on the right, we have vCenter there with the host profiles, and then we have the server, and then below we have our Pixie Boot infrastructure. So I'm going to go through this twice because I want to point out a new installation, so the first time you power it on, and then subsequent reboots, and just a little bit of different behavior and how that works. So first thing you do is you power on the box. It goes out and does a DHCP, goes out to the DHCP server, gets his IP address, gets passed over to the TFTP server, who then passes him the name of a file that he needs to download and the name of the server he needs to go download that from. The name of that file and the server is basically the name of the file on the auto deploy server. So then he does a web-based boot off of the auto deploy server, and it's actually an HTTPS. It's a secure boot, and he basically goes out there. And when he goes out there and contacts the auto deploy server, he's going to give the auto deploy server a lot of information. He's going to tell him what IP address he's on, what MAC address he's on, what vendor tag he has, and there's a lot of information. You can use any of this information. You can use some of it. You know, you can use basically everybody on this subnet gets this image. Everybody who's got an asset tag of IBM gets this image. Everybody who's got an asset tag of Cisco gets this image. So you can basically have many different images and many different hardware profiles, and when the host connects to the auto deploy server, it will basically do pattern matching to identify which image to assign to which host and which host profile to assign and where in the cluster to place it. And that's all done using the rules engine. So the host connects, the rules engine goes out and basically uses that pattern matching, and all those rules that are there are created using the PowerCLI interface. And he identifies which image profile, which host profile, and where in vCenter, be it a cluster or a folder, to put the host after he's configured. He then pushes the image, pushes all those VIBs out to the host, and they go directly into memory. The host boots up, connects to vCenter. vCenter then applies the host profile, which configures the host, and then the last step is he will put the host in, you know, the right cluster or the right folder. And now the host is out up and running, and it's ready to host VMs. Okay, so that was the initial boot, so the first time you boot the host up. Now every time you reboot that host, remember there's no disk, so every time you reboot it's doing a network boot. So when you reboot the host, the same basic process takes place in that he contacts the DHCP server and gets redirected, basically told to do a web-based boot off the auto deploy server. Okay, so if he can't find the master image, then he won't be able to boot. So if the auto deploy server is down, he won't be able to boot. So the auto deploy server, the availability of the auto deploy server is important. Another thing to keep in mind though is if he went down, any VMs that were on them should have been failed over by HA, or when it was put in maintenance mode, would have been evacuated. So just because the host goes down doesn't mean you should have VM downtime. If you've architected it, you've got HA in place, you've got the tools, you know, so the host goes down, yeah, it may be a little while before he comes back, depending if your auto deploy server for some reason becomes unavailable, but that's a design consideration you do need to take into account. Yeah, I'm not really sure. Yeah, I understand the question. So,
in other words, if you want to run your auto deploy system in a virtual machine, it's got to be coupled to a different stack, obviously.
Okay, so if I understand what you're saying right, you're basically saying that the auto deploy server should be separate from the. Yeah. Okay. Well, let me get through this, and then questions. We'll get to the end. We'll have the questions. But yeah, there are some design considerations, and we could talk about those. Okay. So the point I want to make here, getting back to the slides, is on the subsequent reboot, when the host reboots, instead of having to go to the rules engine every time, the information about which host profile, which image profile, and where to place it has been saved on the auto deploy server. He retains that information. So the next time the host boots, he just goes and he gets that information from where it's information that's saved, or the cache, and then he'll then basically reapply, you know, the image and the host profile and boot it back up. So there's a little bit of a, when you do the reboots, it's not always hitting the rules engine. So just kind of a little bit of difference there between a regular initial boot and a follow-on reboot. Okay, so that's auto deploy in a nutshell. The back's not working. I was thinking there was one other thing. Okay, so one of the things that the slides doesn't really show here is when we talked about Image Builder, we had examples of the actual commands that were used to create the image profile. There's PowerCLI based, and they're all commands that you use to basically create the rules to assign host profiles and do all that. So. Okay, so the question is, okay, so a little bit of confusion about the difference between the initial boot and the follow-on boot, and where's the information stored? The information is stored on the auto-deploy server. Okay, so let's go ahead and let's get into the operational considerations, some of the things to think about after you install some of the post-migration tasks. I'll bring David back in, and we'll just go through these slides, and we'll be able to just kind of give you some kind of best practices, some recommendations on things to, when you deploy, some things to look for, some things that are new with 5.0. So we'll start out. David, you want to go ahead and go over the Update Manager?
Yeah, so I'll just wait for my mic to get turned off. How's that? Be better? Yeah, there we go. So looking at the install process of obviously upgrading existing infrastructure, we've seen the key role that Virtual Center Server plays in this auto-deploy function. So some things to note about Update Manager. Once Virtual Center Server has been upgraded, the next step that we'll do is upgrade the Update Manager itself. Now, one of the key changes is we no longer support guest OS system patching. Right? So what we're going to do is we're going to upgrade Update Manager, and you can do that directly from the vCenter Server installation screen. And once that Update Manager is in place, you can then do your VMware tools and your hardware upgrades for the different virtual machines. And we can now remediate multiple servers simultaneously, and you can schedule the reboots of those servers, VMware tools installs, ESX to ESXi migration installs and updates. So we can choose to do those at low business times or at scheduled maintenance windows. You want to go on to the next one?
Okay, so a little bit on the scratch partition. So with ESXi, there's a scratch partition, and that scratch partition is used to store logs as well as other information on the host. If you run VM support and you do a log bundle, it will use a scratch partition. So when you first install ESXi, the way it works is the first gig of the disk gets partitioned for the ESXi image, then it will create it'll take the next 4 gig of that boot disk and create a scratch partition, and that gets mounted up at /scratch. When you go into an environment where you're using auto-deploy and you don't have a disk, it's very important that you pay attention to where your scratch partition is, because if the installer is unable to find a data store, a persistent place to put the scratch partition, it will put it in VRAM and a RAM disk in memory. And you don't want the scratch partition in memory, so it's good to, as a kind of a post-installation consideration, something to check. Go out and make sure your scratch partition is on a persistent data store. Make sure it's where you want it. You can go in and you can set it through the host profile if you're using auto-deploy. But you do want to check, make sure your scratch partition is on a persistent data store and it's not in RAM disk. If it's in RAM disk, everything works. It's just you're taking 4 gig off your host that could be better used serving VMs and doing better things than just as a scratch pad or a storage area where I can put my logs. The other thing to keep in mind is if you're using the scratch partition and it's in memory, every time you reboot, you'll lose your logs. And so you can create a situation where you have a problem, you reboot the problem persists, you call support, they ask for logs, you sip them the logs, and the logs are empty. So the scratch partition, it's important that it be on persistent data store. Watch it, because there are scenarios where it can end up in a RAM disk, and it's kind of subtle. It doesn't come up and tell you, hey, I'm putting it in a RAM disk. It just does it, and you don't know it until you go in and check.
Correct me if I'm wrong, but you can also create a single scratch partition for multiple servers, and I think the recommended size is 20 gig. Is that?
Yeah. So if you're doing SAMboot, or if you're you have a lot of hosts and you want to have a centralized place, you can go ahead and have one LUN or one disk and have many hosts sharing that for their scratch partition. So. Kind of following along those lines. When you install the vSphere 5.0, the vCenter 5.0 installation media, you'll notice there's some new options here. The bottom option there, actually, where's it at? Yeah, there, the auto deploy server, so that's new. That's how you install the auto deploy server that we talked about. In addition, you'll see you got the dump collector and the syslog collector. So your logs. So like I mentioned, logs go in Scratch partition, and it will try to put the logs on a persistent data store. Well, if I'm in a diskless environment and I'm booting off memory and I don't have any disk other than my shared storage, where do my logs go? I don't want my logs in memory. So what you need to do is set up a remote log host. You need to set up a server on the network that you can use do remote logging to, using syslog. And that's exactly what the VMware syslog collector is. It installs on Windows and it basically sets up that remote log host so you can have all your hosts logging to this host. So you just put it in, you install it, it sets up that syslog server, then you go into your host and you point your host to that log server and they will log to that log server. In this situation, it's very important that you have your time in sync, because if you're looking at logs on one server, and you make sure the time's in sync so that if you're comparing things, you're not looking at an event at 11:05 when really it was 10:50, stuff like that. The dump collector, similar to the log collector, when if a box psods or if it dumps a core dump, it will dump it to the Scratch partition. If that's in memory, you reboot, you could lose it. So it's important with auto deploy in a diskless environment to go ahead and point that to do a network-based dump, so it will dump to a dump host. And again, so the dump collector does that as well. This is not just applicable to auto deploy. For a lot of people who run large environments, they choose to do this type of network logging and set up a network dump host, even though they have local disk, because it can kind of help with troubleshooting, consolidate everything in one place. So that's what the new options are. When you look at the 5.0 installation, this is all part of the installation media for vCenter. And so I just want to point out what those are for.
Sorry, just before you move on, note the auto deploy here. Once you choose the auto deploy installation, you can do this from the virtual appliance as well. What that effectively allows you to do is get a download point for the GPX image that you're going to put into the TFTP server. So that's basically what that's doing, is saying, okay, there's a file, the GPX file that you dump into TFTP, so that you can give your DHCP server something to point to. So if you're trying to get auto deploy running and you notice you haven't got the icon under the virtual center server, just go and hit this installation here, and that'll create that file that you need to put into TFTP. Right, so that's how it all links in.
Yeah, question? Can you still use VMA? So the question is, can you still use VMA? Yes. So can you still use VMA as far as for like a syslog host and for, yes. So yeah, so VMA works just like it has in the past. It's, it's still there. So VMA I think everybody probably knows, but just to make sure. So the vCLI, the service console is gone with ESXi. We replaced it. We have command line tools, vCLI, PowerCLI, and you can install those. And vCLI is the one version of the command line tools. You can install it on Windows or on Linux, and you can also go out and get it as an appliance, and that's the VMA, the virtual machine appliance. And you basically just deploy it, and you can use it. The VMA comes with many things in addition to, you can use it as a syslog host, so that's still there. Okay, VI Logger, yes, is deprecated, but the FastPass and everything else is still there. Okay, that may be the case. I didn't think about that being deprecated, but yeah, he brings it up that is. So you may need to double click on that, maybe look into that, see if we can use the VMA for syslog collection. You're not forced, you don't have to use the syslog collector, the Windows-based syslog collector. You can still use Unix and you can still use a remote syslog. It doesn't have to be the Windows. This is just one option. Now, whether or not you can do it in the VMA with the logger gone, I'd need to double check on that. Here's an example of how to set that up. So really what I want to point out here in this screenshot is if you go into the advanced options, you'll see the syslog is there. And you'll see underneath you have global settings. And under global settings, you have the log directory. If you're using a data store, and up here you also have there's an option in there for the log host, syslog global host. So it's easy to go in and set that. You can do it from the command line. You can do it from the vSphere client. In addition, the dump collector works pretty much the same way. Once you set it up, you basically go into advanced options. In that same screen, there's an option there where you can set that up as well. One note about the vCenter server appliance. So we talk about auto deploy, we talk about the syslog collector, we talk about the dump collector, we talk about how they're all kind of add-on components that you add on to your Windows vCenter. If you're running the VCSA, the vCenter server appliance, which is the new web-based virtual center, these are all bundled with it. So auto deploy is already pre-configured and already there. The syslog collector is already there. The dump collector is already there. So if you're using the web-based VCSA, there's no additional installation as much as they're included with that. If you're using the Windows, you have to add these components after, after the fact.
That's why the appliance is something.
Yeah. So lockdown mode is important when talking about deployment considerations. So essentially what lockdown mode is going to do is it's going to limit access to your host to only people who are coming through the vCenter client. So the reason you might want to do that is because you don't want people to be able to backdoor and be able to get access to the console and be able to do things without being logged. If I do it through the vCenter client's going to log me and people are going to know what I'm doing. If I log on the console, I can run some things and maybe backdoor. So it's a security thing. Also, a lot of us have servers that are in different parts of the country, and we don't have access to we don't have control over who has physical access to those servers, so we can go in, enable lockdown mode, and basically limit that access so that we can be sure that people are using the vSphere client, everything's getting logged, and we don't have any security issues with regards to people being able to access and do things on the host without being, being monitored and audited. By default, it's turned off. You turn it on, simply go into the DCUI, which we see the screenshot here, and just hit configure lockdown mode. You can also enable and disable through the vSphere client as well. ESXi troubleshooting. So the tech support mode has now been renamed to ESXi Shell, so a little bit better name. And similar to in the past, it's disabled by default. You can enable it, and when you enable it, this basically allows you to get a shell on the local host for doing troubleshooting. Typically, we like to recommend that you not use the ESXi shell as part of a day-to-day operation. If you're going to be using something that frequently, you should be using the vCLI or PowerCLI or using the API. This is more for a troubleshooting scenario. You're down, you need to get on the host, you need to be able to do some checking, then go ahead and use the ESXi shell. In addition to the ESXi shell, you can access it remotely using SSH. You have to enable both options. They're independent. So you go in and enable the ESXi shell, and then you go in and enable SSH, and you can SSH to the box, and you can run commands. One thing about the ESXi shell that is new, that is significant, is the ESXCFG commands that most of you are probably familiar with in the service console, the old ESXCFG commands. Those commands have been deprecated in 5.0. They are now replaced with the new ESXCLI command set. The ESXCLI commands, they run both locally from the ESXi shell as well as remotely through the vCLI. So it's a first step towards providing a standard command line interface for both local and remote host administration. If you enable ESXi shell, if you enable SSH, vCenter by default will give you a warning. A pop-up that basically tell you, hey, you've got these things enabled, and you can disable that if you want, but it's really there to remind you that, hey, these aren't things that should be enabled all the time. Remember to turn it off when you're done. And again, the recommendation is to make sure you take some time, learn the CLI, the vCLI, PowerCLI, and as those are really what you need to be using to manage your host. Kind of following along that, here's an example of your command line options. I kind of got a little bit ahead of myself. So the ESXi shell, again, that's that rebranded tech support mode. You can access it from the console or via SSH, and it has that new ESXCLI command. People who have used ESXCLI in the 4.1 days, you're familiar with the command. It's the same type command. It has the command namespaces. It's kind of a self-discovery syntax, but do be aware that the namespaces have changed. The syntax is the same, but the names of the namespaces, some of the names of the commands have changed. So if you have a script that runs today on ESXi 4.1 and it's using ESXCLI commands, you'll probably need to modify those for 5.0 to adapt it. In addition to the ESXCLI command and the ESXi shell, you have the remote options, the vCLI. Again, vCLI, a lot of people associate vCLI as Linux. You can run vCLI on Windows as well. So it has a Linux and a Windows version. If you don't want to install the vCLI separately, you can get the VMA and install it as a package. In addition, you always have the PowerCLI option as well. ESXi, I talk about it. One thing to just bring up about the ESXi is in 5.0, it is not a full comprehensive CLI. You will continue to augment it with VICFG and other commands that you're familiar with. So I think the table coming up here, yes, this table kind of shows you a summary of the vCLI options in 5.0. So you'll notice up there, ESXCFG is no longer supported in 5.0. That's deprecated. The commands are still there. You can still use them. They still work. It's just that they're officially deprecated, meaning that going forward they may drop off. So you need to start getting in the habit of breaking away from the ESXCFG and using the ESXCLI equivalent. You'll notice the ESXCLI works the same remote and local. And then you have the other commands that you're probably familiar with, the VICFG, the VMware command, VMKFS tools. Those are pretty much the same as in previous releases. So that's kind of your toolkit arsenal for managing your ESXi 5.0 host. Okay, so that's pretty much all we got. We'll open up to questions and answers. Yeah, go ahead.
I had a question about your vCenter add-ons. You mentioned best practices. Are any of those separable or dependent on being installed inside the vCenter server itself? Not the client, but like the auto deploy, or those best practices to put them on separate server, physical VM or whatnot?
Yeah, so the question is, when it comes to the add-on components, syslog collector, dump collector, auto deploy, should they be on the same server as vCenter? Should they be on separate servers as vCenter? Can you co-locate them? Pretty much the recommendation is keep them separate, simply because vCenter is doing a lot, and so by keeping them separate, you can kind of help disperse that workload. Running them in VMs is great. Auto deploy, we talked earlier about auto deploy and how if auto deploy goes down, you can't reboot a host. Put it in a VM, it helps make it highly available. In a small environment, in a test environment, co-locate them, that works great. As the environment grows, you may want to look at branching those off so that you don't overwork the one server. You go to the distributed model and get better performance. That's kind of the general idea.
With Update Manager removing the SOS updates, it has some pretty stringent requirements in the large environment in terms of memory and disk usage that greatly restricts them, or simply something to keep the vCenter.
Yeah, so the question about Update Manager and removing support for the Windows-based patching. So there are going to be a lot fewer patches come down. So the size of the data, the patch repository, maybe you won't have as much information in there. All the patches will be focused specifically on ESXi and those applicable. So I would say it probably is going to reduce the size of the data store you need because you're going to have a lot less patches. But other than that, as far as host and CPU, memory, the requirements are probably about the same. For best practice, there's a lot of information online. There's some what's new guides. We're working on some recordings. There's an evaluator's guide. I don't know if anybody's familiar with the evaluator's guide. Go out, get the evaluator's guide. You can get it from the same site where you can download it, and it will walk you through how to install this stuff kind of as an evaluation. And in there we give a lot of good advice about, okay, here's some things to watch for, here's some things to avoid. The biggest thing with both auto deploy and image builder in 5.0 is they're PowerCLI based. So if you're not familiar with PowerCLI, there might be a little bit of a learning curve. There's no GUI right now. So if you go in and you use those auto deploy guides, we can kind of help provide you some information on how to get through that. Yeah. So the question is there an update bundle to upgrade to vSphere 5? Yes. Well, it's not an update bundle. So with vSphere 5.0, you can now upgrade directly from ESX and ESXi 4.x to ESXi 5. And the way you do it is you basically just import the ESXi 5.0 image, and you create a 5.0 upgrade baseline using that image. And then you basically just go and attach that image to your 4.x host, and you right. Yeah, and it will keep the configuration. So, and that's true for both ESX and ESXi. VSP3307, the other kind of partner session to this, I go into that in basically a whole hour. I talk about that exact thing, how to upgrade. Yeah. So as part of your upgrade from 4.1, you want to also start using auto deploy. And so what's the best way to do that? The best way to do that really is, remember, auto deploy is going to use the host profiles. So you're going to want to upgrade one host first, and you're going to want to just upgrade it as a normal host. Then once you get it upgraded, create the host profile as kind of your template. And then as the other hosts come in, use that host profile to create it. But other than that, it's pretty straightforward. You just got to make sure your Pixie Boot environment's there, and you just basically, when you boot the host, he'll DHCP boot up off the auto deploy server, and everything will come up. But the trick that I find personally for me was, the host profile is kind of a chicken and egg thing. I need the host profile to configure it, but I can't configure it. I don't have the host profile. If you don't have the host profile, it will boot the host into maintenance mode. So auto deploy will boot it up, it will connect to vCenter, but it will be sitting there in maintenance mode. So that's another option. Get it in maintenance mode, but you will need to get the first host up. And if I have like a mixed environment where I have HP, Dell, Cisco, you'll need to have a separate host profile for each platform. And so you go in and create those, and once you get the host profiles worked out, then it's pretty straightforward. Yeah.
As a deployment consideration, would you recommend doing like the auto deploy, syslog, the log gather as a VM, maybe bulk tolerance?
Yeah, so the question is, would it be a good idea to put these add-on components, the auto-deploy server, the syslog server, these, in a VM and enable FT? For auto-deploy, no, simply because auto-deploy, you're going to need to have more than one CPU. For the syslog collector, the dump collector, yeah, that would be very good. You create those, use FT to protect them. Now, the reason why auto-deploy is going to need more than one CPU is, remember, we're doing a secure web boot. So if you have a 5-host booting up and you got the auto deploy server sending out those images, he's using encryption, SSL, to send those out, and that's going to tax the CPU on the box. So you want to make sure your auto deploy server, you take that into account, have some, couple CPUs and can handle that workload. So I think there's a couple of questions over here still. We'll go over here. Yeah. No, it is only PowerCLI, requires PowerCLI only. There's no additional installation. All you do is just install PowerCLI, and it's a snap-in that's included with it.
And then I noticed that there's still no GUI configuration for syslogging level. Is that true?
For the syslog level? Verbosity?
Was that on there?
I think in advanced settings you can...
In the advanced settings, you can go in and set all those syslog settings. Did that answer your question back here? Yeah, go ahead.
Are NFS mounts supported for the syslogs?
Yes. Yes, you can put the scratch partition on any data store. So basically what it is by default, we'll create a partition and we'll mount it up. If it's in RAM disk and you want to change it, you can go in and you basically just give it a path to a data store, and it will write the logs there. Yeah. Yes. Yes, you can do that. Technically, it works great. That's what I do in my labs. The only concern you're going to have is performance. If you have auto deploy and vCenter together, and you have a rack go down and you're powering up 30 boxes at the same time, you're going to basically have a pretty big hit on that guy. So in that environment, you may want to separate architecturally for that reason. But as far as any limitation, run them together, no limitations. Yeah. Yes. So as you scale out the auto deploy environment, reverse HTTP proxy, have multiple, and then you can set that up so that these guys will use this guy, these guys will use, so that way if you have like a total data center outage and you're booting up hundreds of hosts, you can kind of distribute that workload. Yeah.
Back to his question, it still sounds like you have to like splitting subnets, say these 20 hosts use this auto deploy, these 20 hosts use that, but is there a way to have some storage fault tolerance where we can have HA where 2 or 3 auto deployment servers, and if one goes down and the hosts that we're using that reboot, they can pick another auto deploy server?
So there's nothing within vSphere allow you to do that, but you could like set up some type of DNS round robin or something, so when the host boots in DHCP and he goes out to look at that server, he can be some type of load balancing. You can have some type of load balancer in front of like 3 auto deploy servers. And so you can do it at the infrastructure layer, but there's nothing within the auto deploy server that basically maintains a table of multiple servers. So you can kind of accomplish that, but there's no list of auto deploy servers and in vSphere where we're going to distribute them.
So when managing in auto deploy servers, I have to define my host profiles for each one
If you had 3 auto deploy servers, you're going to have to go in and create those rules 3 times. There's nothing right now, if you have 3 auto deploy servers, where they'll share the configuration. Now, if you're using the reverse proxy, if you're using them as kind of a proxy and stuff, then you basically have to come up with a way to kind of keep those in sync. So if you make a change to one, you have to somehow propagate those changes to the other one.
In theory, once it's set up, it's set up, right? Then it's hands-off.
So, yes, you can. So basically what you do is you just install the OVF multiple times and just turn off services. And so that works. Any other questions? Yeah. Yeah, Scratch Partition. The question is, Scratch Partition, should I put on fast storage? Scratch Partition there is primarily logging. And it's not really that critical that it be high speed and fast. So I really wouldn't worry about dedicating a fast LUN for it as much as just a LUN where you have space. Yeah.
Rebooting a host, how much data gets sent across the wire? We're talking, whole gig.
So the ESXi image itself is about 350 meg, and you're copying that over the wire, so 350 meg. So the image itself is 1 gig. The image is broken out into a couple of boot banks, and the hypervisor gets installed in the boot bank, and the actual hypervisor, the VIBs and everything. And again, this is where the image builder comes in, because if you have 350 meg of VIBs, you can remove ones you don't need and get that down to 200 meg. I mean, you can add and remove as you need. It's the size of that gets copied. So what happens when the host boots up, it loads that 350 meg into memory and basically instantiates the hypervisor and comes up. So it's not like we're copying that full 1 gig. So, yeah, over here.
To be clear, that I understand it right, if you have a VM, that's your on-deploy to your VM, and your hosts are all doing it. If you have a data center power outage, you're screwed, right? Because there's no way to bring up a host. No host is going to come up, right? Because there's no on-deploy server, right? I mean, you're going to be at that point.
Well, if your environment's completely on auto deploy and it completely goes down, then you're going to have to manually go in, power it up manually, and get that vCenter up, get that auto deploy up, and then bring the rest up. So when you get into best practices, does it make sense to maybe have kind of an infrastructure cluster that's hosting your vCenter, hosting your auto deploy that's not based on auto boot? Potentially, yes. Again, you want to think about this because the auto deploy server outage will impact you. Its impact, you can architect around it. So what I've recommended to others is go ahead and set up a management cluster. In that management cluster, have your auto deploy server, have your vCenter server, and then have the rest of your environment that's using that auto deploy. And then that way, if you have an outage, you can just boot these guys off local disk and then bring the rest of it up. Right now, there's no ability to call like pre and post install scripts and stuff in the auto deploy. So yeah, that would be kind of hard to do with auto deploy right now. So like some of the other Pixie Boot solutions, you can do that. With auto deploy, since there's no real ability to tie in scripting, it's kind of hard to accomplish some of those things. I guess that's our clue. We're done. Thank you.